What if you could build your own cloud infrastructure like Lego blocks? Fast, flexible, and perfectly reusable. That's the power of composability in the cloud, where resources adapt to your needs. Hi, I'm Ashutosh Mahapatra from Computer Science, and I'll be discussing about composability in cloud. So, what is composability? Composability is a property in the cloud where individual modules are combined together to form a whole infrastructure, which then assigns resources dynamically to the cloud clients. So, now let's talk about the aspects of cloud. So, first thing is the modular architecture. What do you mean by modular? Modular means we will use independent components throughout the making of the cloud. Then the second one is the interoperability. What is interoperability? The clouds which are used to make the cloud infrastructure are combined in such a manner that they can communicate with each other without any interaction. Third is the scalability. We can scale up and down those components whenever we want. Third is the resilience and fault tolerance. Fourth is portability. So let's talk about how this composable architecture is structured in cloud computing. So there are generally three layers in this composable architecture. First is the application or the top layer, then there is a middle layer, and there is a bottom layer. So first is the application and tools, which consist in the application or the top layer, which generally a medium to communicate with the clients. Then second is the bottom layer. This layer consists of two components. First is the management API and the second is the logical resource pool. So this management API is the medium or the application programming interface through which these applications talk with the cloud. Then there is a logical resource pool. These resource pools are logical because there is a component known as virtual machine which help those physical resources converted into logical resources. What are those logical resources? First is the computing environment, second is the storage, and third is the network. And lastly, there is a bottom layer which has three components. First is a bare metal, there is a virtual machine which is a software, and third is containers.
What if your applications could be built like a playlist, mixing and matching only the services you need? Why you need them? That's the power of composable platform and microservices, where software is modular, scalable, and built for rapid innovation. My name is G. Khetraj Reddy, and let's talk about composable platforms and microservices. Composable platforms like Kubernetes, Docker, and OpenShift provide a composable environment where microservices and centralized applications can be orchestrated. What are the composable platforms? Composable platforms offer pre-built modular services that developer can integrate into their application. These platforms provides configured modules, API-driven architecture. Pre-configured modules refers to services like database, authentication, and logging, and API-driven architecture allows developer to integrate external tools and services seamlessly. Develop compatibility supports CI/CD pipeline and automated developments. Role of microservices in composability. Microservices architecture is one of the best examples of composability in cloud computing. Each service operates independently but can communicate with each other by APIs. Benefit of microservices: independent scaling, better fault isolation, continuous development. Then this diagram represents key features of composable systems using hybrid approach. A system can be built from individual components or connected with existing ones. The core features of composability and microservices are modularity, flexibility, scalability, and interoperability. Modularity refers to breaking the whole entire system into smaller and reusable parts. Flexibility, adapting easily to new requirements. And scalability refers to expanding as needed without major changes. Interoperability, that ensure different components should work together. How do independent cloud components talk to each other without chaos? Through well-defined communication protocols, ensuring seamless, secure, and efficient interaction in composable cloud system. Hi, I am Kamalakan Paida. Let's talk about communication protocol in composable cloud system. Imagine a world where without seamless integration, the cloud is working.
like your email does not sync at all, you are gaming and your game is lagging more. So by use of cloud communication protocol, we can handle this. Let's talk about network communication protocol. What network communication protocol does? There are several types of protocols are there. TCP, IP, UDP, HTTP, HTTPS. TCP, what does TCP? TCP is known for reliable data transfer. Then comes into UDP. UDP is not reliable but it is very fast. Then HTTPS, it does several works in cloud computing by securing your messages when we're transferring your data to another server. Message application protocol. Imagine you are using a WhatsApp web or any cloud-based chat application. What will happen? You have to receive instant time message. So message application protocol works in here. The MQTT, the AMQP and the REST API works here to provide a reliable messages. Then comes to our security protocol. What security protocol does? Imagine where we send our data into cloud. IPsec used to encrypt your data. Then comes into OAuth. It used to authorize you in your cloud server. Then come to our storage and data transmission protocol. What is does? Where we are saving our data in a cloud server. So by the use of these protocols, we can send our data and retrieve our data through these protocols. That's NFS and SMB. After that, if you watching a movie or playing a game, then you know whom to thank.
If composability makes the cloud so flexible, why is not everything fully comparable yet? Because challenges like integration, complexity, latency, and security still shape its future, but innovation is closing the gap first. Hello, I am Neer and Atullah Kadri. Let's talk about challenges and future of composability in cloud. While composability offers numerous advantages, there are also challenges that organizers must address to fully leverage it. Challenges: complexity in management. As more components are added, maintaining, orchestration, and monitoring becomes complex. Second, security concerns. Each composable unit must be secured individually, increasing the attack surface. Interoperability issue. Different cloud providers may have incompatible components, making migration difficult. Fourth, performance overhead. Communication between microservices can introduce latency. Future trends in composability. AI-driven automation, machine learning will optimize resource allocation dynamically. Serverless computing growth. More applications will shift to event-driven serverless models. Fourth, edge computing integration. Composability will extend beyond centralized cloud environments to edge devices. Standardization of APIs and protocols. Efforts are being made to create universal cloud interoperability standards. With continuous advancements in cloud computing, composability will play a key role in making applications more scalable, modular, and efficient.